So um, I have two ideas to actually talk about. I feel like um, number one is whatever we discuss over here. Number two is what I'm about to discuss, which is happening over there, and I'm gonna try my best to talk about that. What I think is that the final output over here is one, and you are utilizing all the ingredients over here, which is will be your two, and I just gonna like elaborate more, find out from the two how we can actually break it down to make it understandable, and what are like the main mechanics that they are actually utilizing to actually be able to get to the one. In my opinion, there's only two items that they are using. They are using A and B as part of their ingredient to actually solve this whole thing. So in A, is first and foremost use the imaginary one and then multiply by 1, you get a 1. And I just suddenly thought about how we can actually um, derive from the plane 2 into the 1. The main mechanics that is actually talking about is that, let's say I want focus on 2, right? So I need to multiply the people that who are outside of 2. So 1 times 3, 3, right? 3 times 4, 12. That's for the answer 12. So we go on to the next one. Draw a line. This time around we are focusing on 3. So multiply everything outside 3. 1 times 2, 2. 2 times 4, 8. Therefore 8 over here. And same for go for the number 4. You are multiplying everything outside of the 4. So 3 times 2, 6. 6 times 1 is still a 6. Therefore you have a 6 over here. And then you kind of rinse and repeat for every single thing. And now their question is, how do you actually use the raw of the 2, right? That is the raw. So I'll term this as how did they actually what is their plan to make z into y? How can they actually simplify z that they can actually use? So what they actually utilizing the main mechanics of using a prefix and then the postfix. So I'll say that z is the complicated one. And they are just simply transforming the z into a x, which is a simpler version of z, right? X is a simpler version of z. So why does x works? I think why x works is because you are summing up, accumulating the byproduct from say the left hand side. So prefix, how it works is that maybe we go by a, right? This value is a byproduct of the left side and this one. 1 times 1, 1. 1 times 2, 2. 1 times 2, you get 2. You 2 times 3, you get a 6. 6 times 4, you get 24. So I'll say that it's a accumulating byproduct. I feel like when we talk about this value, we are byproducting this, and when we are having this, we are multiplying by the byproduct of this, which doesn't seem so obvious. When I want byproduct of this, I think first and foremost is that the more obvious one I think will be this one, the 6. So what 6 comprises is the byproduct accumulation from 3 onwards, which is 3 all the way in, and the byproduct of 24 is the accumulation of like 4 onwards. For this case, 4 times 3 times 2 times 1. And how do they actually make it possible is that first and foremost, they're 1 times 1 equal to 1. So this value is the byproduct of whatever's been byproduct on the left hand side from here onwards. 2 is the byproduct of 2 onwards, which is from here all the way to here, with the imaginary one obviously included. So for this 2 value is 1 times 1 times 2 equals 2. And for this third slot, it's basically the byproduct of like 3 onwards, which includes this imaginary one as well. 1 times 1, 1, 1 times 2, 2, 2 times 3, 6. That's why it's 6. And for the 24, we will be the byproduct of like 4 onwards, which is having the imaginary 1 times 1 times 2 times 3 times 4. So 2, 6, 24, and then you get a 24 here. I think the focus down here is that we are saying that it is byproduct from your current element all the way towards the left hand side per se. So for this one, you byproduct all the way. And the beauty of that is that what they are actually abusing, if you were to actually see, is that for 1, so I'm just going to draw a line to let you visualize better. So for 1 is the byproduct from here onwards, right? And for 2 is a byproduct from here onwards, and 3, and then 4. So I think the thing that what prefix is abusing, what A is actually abusing, is that it's abusing that the value that is being calculated from here onwards, so that you don't really need, when you want to calculate for say we have A, B, C and D, right? What you're actually doing is that for B, you don't necessarily need to count from scratch, which is say I need to calculate the imaginary 1, calculate the 1, and then calculate my multiply by 2. So as opposed to calculating every individual from scratch, 1 times 1 times 2, what I'm actually doing is that I'm going to use the value that I calculated from A already, and then just multiply by what I have in my current element over here, which is the 2, right? So as you can see, it's a 2 over here. I just multiply by A, which is, for this very case, it's 1, and therefore I get a 2. Let's try for C. So like if you were to actually do a brute force for this value, right, what you actually intuitively do, your 3 times 2 times 1, and that gives you the 6, because 3 times 2 times 1 equals 6. So what we do prefix in the stage 2, instead of doing 1, let's do 2 instead. How 2 actually comes about is that use the element of like C, which is for 3, right? You just multiply by the calculated value by B, which is 2. 3 times 2, you straight away you get a 6, which is the similar answer. Let's go for D as well. So originally you do calculate every single element, which is stage 1, how we actually calculate. 4 times 3, 12. 12 times 2, 24. And there you have the answer, 24. Let's do the stage 2 on how they actually do it. The element in fourth, in D, which is 4, I just calculate the number value for C. So 4 times 6, I get 24. It's the same answer. I don't need to go about to actually calculate every single thing from scratch. So as opposed to calculating from stage 1, I just abuse the previous calculation that I did, which is for A, B, and C, to calculate for D. And that what we actually explain the power of prefix byproduct. So I believe for A, the difference between A and B is the direction. For pre, it's going the direction of left side. As for post, it's basically going the direction of right side. This is the opposite side. So we're gonna use stage 2 way of calculating for B, right? So first and foremost, we have the one imaginary over here. One times 4, 4. 4 times 3, 12. 12 times 2, 24. 24 times 1, 24. So I'm using the stage 2 way of calculating. If I use the stage 1 to actually calculate, it will be like this. 4 times 1, 4. 3 times 4 times 1, 12. 2 times 3 times 4 times 1, 24. 1 times 2 times 3 times 4 times 1, 24. So that's the difference between stage 1 and stage 2. Obviously, you want to use the stage 2. Stage 2 is so much less elements involved. You are abusing your previous records of like A, B, and C. And now how do we actually use these 2 to be transferred into the 1? Which is the very first thing that of the thing that we wanted to calculate in the very first place. So remember how we actually started off by saying that we draw this imaginary line and calculate all the values outside of 2. So now we know how like pre and post works. Pre is calculating all the byproduct all the way here, and post is calculating all the right side values, right? So how can we abuse this? We just basically use both the pre and the post for the left side barrier, which is, for this case, is 1. Outside of here onwards towards the right, it will be 12. So 1 times 12, I get a 12. And we move on to the next one. Use the pre because it calculates all the way to the left side for this one. Post for this side, for the right barrier onwards, this one. So it's 2 times 4, and then I get an 8. And that's how you actually abuse the A and the B to actually calculate your final output in stage 1. So that's how you transfer from stage 2 to stage 1. And at the very start, we did actually talk about like the easy and hard. So what's with the easy and the hard thing? Honestly, I feel that number 2 is an inconvenient hard. I do feel that what's more important is whatever we've discussed so far earlier on, which is the stage 1 of the easy part. And as you can see, this easy is not really that easy. It's so much more that you got to actually peel off the onion layers to actually learn that that this whole mechanism is so powerful, I would say. So what the stage 2 is actually pretty much actually doing is that you have a pre-calculator over here. So what we basically am going to do, right, is that our A value, we're going to pre-store the A value into this C array. And then what we're gonna do after is that use the B to multiply by C, and then we finally get the output answer. So what they actually do, they have like a temporary value which is stored over here to run us through this whole value to calculate for the prefix and then for the prefix after. So stage Z is to go through prefix, stage Y is to go through postfix to multiply with the values that stored in the C array. And after going through Z and Y, you straight away get the output array as the final answer. And this X is just a temporary value to accompany with the Z and accompany Y. So pre for this, I think there's an imaginary one. So you want, so you go through by z first place first, right? So imaginary 1 multiplied by 1, we get 1, right? So the thing about this is that you do need to be very aware of where does the pre it's occupying the space at. So for this imaginary one is used to multiply by the 24, and this one is multiplied by this is included to this, and what you actually need to know is that on this stage 1 we actually already discussed on why the prefix that's being stored correspondingly. So this one is over here, and the 1 locates over here, 2 locates over here, 6 locates over here. Because I'm just going to give one example, maybe say for the 6, is that you have, let's do with this one, the 3 one, because we already have the 2 barriers out. So when you have these 2 barriers out, remember that we do use the prefix value from outside the barrier, which is outside barrier of 3 is this 2, and outside right barrier will be the postfix of here onwards, which is this 4. So that's why the allocation of the product it's placed accordingly. It's all pre-planned out. If you already understand about the logic case about 1, you'll be able to actually follow up with a logic case number 2. So we're actually using the similar method. So what we actually have here is 1 multiplied by this 1. We do get a 1, and one thing to take note is that once we actually have the value of the value, we straight away store the value into the array C. So the imaginary one, we straight away already storing the value to C. So it's an automatic process. So 1 stored right over here already. And then once we calculate, so we got a pre, right? So 1 times 1 get a 1. So we get a 1, right? 1 straight away store to array C, which is over here. And then now we use the 1 times the 2. So we get 2, right? So our 2 stores us here, and 2 stores to the array number C, which is over here. So there will be a 2 over here, a 1 over here, a 1 over here, right? Similarly, 2 times 3, it gives us 6, right? So store a 6 as being placed over here as well. So then we move on to the post. So we have imaginary 1 over here. We multiply by this one. 6 times 1, 6. So so now our poles are, which is this 1 times 4, get a 4, right? So place the 4 over here. 4 times 2 become 8. So 4 4 times 3 get a 12. So 12 is over here, and be multiplied over here. 12 times 2, 24. 24 store over here. And then as you can see, 1 times 24 is a 24, 1 times 12 is a 12, 2 times 4 is a 8, 6 times the imaginary 1 is the 6. So that's the solution for this solution for number 2. There you have it. Everything comes to an end.